Okay.
Meanwhile, should I call Sampath?
No, let him come. Let him come. You need not.
Okay.
Okay. Okay. The next thing which we will start is MST. Okay. Which is nothing but, how many of you know this? At least you have read in college, everyone for sure.
Minimum spanning tree.
अरे definition नहीं भाई, ये बोलो कि क्या है, what is this? Manan, do you know MST?
फर्क
Sorry?
कट शायद तब याद था, अभी याद नहीं है, I don't remember now.
Nice.
तब याद था.
एग्जाम के लिए पढ़ लिए, हो गया. Okay. So see. So do you guys remember DFS tree? How many of you remember DFS tree? We took a very, we actually grilled 3 kind of edges: forward, backward, cross.
Yes, yeah.
Okay. So see, so given a graph, when you do a DFS, can I say always a tree will be produced? Always a tree is being produced, right? So now MST is given a graph, okay? Given a graph which will always be a weighted graph, okay? This is a one tree. This is one tree, correct? There can be another tree, something like this also, right? So for a graph, there can be multiple trees, right? Trees means when you do a DFS, you get some kind of tree, correct? Out of all of them, okay, out of all of them, so you have some weights associated: 5, 7, 9, 2, 1. Here you have 3, 2, 1, 9, 7. Out of all the trees, you have to, so these are known as spanning trees itself. Spanning trees are what? It's same as tree, that from each node you should able to reach any other node. Okay, the same properties of tree. What's minimum spanning trees? Minimum spanning trees, the tree which is having the minimum cost. So I guess this is the one which is having less cost, right? 3, 5, 6, 13, 22. This is having a cost of 14, 21, 23, 24. This is having a cost of 24. This is having a cost of 22. So this is what you need to come up with. I mean, you need to print 22. Okay. Is the question clear? Minimum spanning tree. Is the question clear?
Yeah.
Deva, is it clear?
एक बार फिर से.
Yeah.
अरे भाई, given a graph, ठीक है?
हाँ.
कुछ तो एक ग्राफ दिया है, रैंडम सा. Okay. There are weights. There are some
Correct.
weights. So there can be multiple trees, right? There can be multiple spanning trees. Correct? One is something like this. एक ऐसा
Yes.
tree हो सकता. This is one tree. Can I say this is one tree? Correct, Manan? So there can be multiple trees, right?
Yes.
Out of all the trees, the one which is having the minimum cost matlab sum of the A wale, 3 plus 7 plus 2 plus 8,
Edges. हाँ.
sum of the edges. जिसका minimum रहेगा, you should print that cost.
Okay.
Others, is it clear? Sam?
Yes, Prakash.
Yeah.
Spanning tree means what, bro? Like
Same
this
as tree only.
drawing this one itself.
It's same
Okay.
as tree only. Okay. The only difference that, like, I mean, there cannot be multiple components, right? If there is a multiple component, it will not become a tree, correct? It will become,
Yeah.
it will become, okay. So if there are multiple components, Sam, okay, and if we do a DFS from each one of them, what will be produced at the last? I told a term. Deva, do you remember? Deva, anyone?
Can
Sars?
you repeat the question?
If we do a DFS from each and every component, okay, we will get a DFS tree, right? correct?
Forest something.
Exactly, it's forest.
Yes.
So yeah, so what I'm talking about is given a graph, you have to find the cost of the MST, minimum spanning tree. Clear? So same as all the properties of tree, that there should not be any cycle. Okay, all the nodes are reachable. And how many edges will be there in a tree given n nodes?
N minus one.
And can you see there are n minus 1 edges in any of the trees whichever I have drawn? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so
Yeah.
since there are many trees possible, out of all of them you should print the minimum cost. Is the question clear now, Manan?
Yes.
Okay, sure, right? You're clear now.
Yeah, yeah.
Kind of don't see the confidence on your
नहीं नहीं
okay,
yeah, it is fine.
chalo. So there are very two popular algorithms which does exist to solve this. Okay, one is
Prism.
what?
Prism algorithm or something.
Deva, new algorithm.
Prism
Name
Club.
listed.
Kruskal's
Chalo. The first
Kruskal's
algorithm.
Prims.
The first
Prims
algorithm is
Kruskals.
SAM's. Okay, which is Kruskal algorithm.
Sam went to Prism Club yesterday.
Mhm.
Prism was
Sam's algorithm. This is Sam's
moving,
algorithm.
moving.
Okay,
Okay.
that is Primson. Okay.
So this is out of my bound. Okay, only Sam can explain this. Okay, I cannot explain because he has derived this and he did not publish paper. So
We shall schedule some other class, bro.
okay, well, sure, we will schedule it, man. Okay, okay. So jokes apart. So there are two algorithms. Okay, one is Kruskal's. The second is Prim's. In our context, we will only read
Yeah,
Kruskal.
I was about to say tell that Primson.
Okay, fine. Okay, so we will in our context we will only do Kruskal because Kruskal is enough to solve problem. Okay, Prim it's थोड़ा kata hai इसमें, so let's go with Kruskal itself. Okay, and it's very intuitive and nice. Okay, and it takes the help of DSU to find it. Okay, so shall we take this graph itself, ये वाला orange graph, and solve it? Okay, let's draw it again. Okay, probably
Yes.
a little better this time. So at least did you guys like the last question, वो tree वाला, मतलब minimum?
Contribution one.
Yes.
Yes, bro.
Yes.
What about contest? How many of you are giving contest regularly? Last time I guess someone didn't give. Oh, Sahas, you didn't give, right? Last.
No,
Myself.
I gave.
Yeah, yeah. Okay, okay. You were sorry, Sam. Yeah, sorry.
I didn't join the discussion, but I gave the contest.
Okay. So this is the thing which we have. Okay. Let me quickly write something. I mean the node numbers. Now, what Kruskal came up with is since we have to find a minimum spanning tree, why not we go with minimum weights? Okay, why not we go with minimum weights? Okay, so initially, do you guys know that everything in the disjoints at union also are dislocated? I mean, everything is a single component, right? Everything is a single component. So what he came up with is let's go through edges in a sorted way, correct? So can I say the first minimum edges this itself? 0 to 6 is having a minimum weight of 2, correct? So let's try to go here and let's pick them up. What's the next minimum weight?
3.
Okay, so we might take anything. Okay, either this or this. Okay, so shall we take, which one shall we take? We'll take, let's 1 comma 3. Okay, let's say this is 4, let's say this is 5. Okay, so what's the next smallest weight? This is done. This is done. What's the next one?
One more 3 is there, right?
So one more 3 we have, right? This is having a weight 3, 2, 3. What's the next smallest weight? What is the next one?
2, 6.
2, 6, right?
4.
So this is the one. What is the next smallest one? Let's say 0, 1, which is having a weight of 5. Correct? Now, can we connect 0, 1? Can we connect 0?
No.
Yes or
No.
no?
Cycle.
Exactly.
No.
So if I connect 0, 1, can I say a cycle will be formed?
Hmm.
So
It's not property of tree.
not property of a spanning tree or a tree, right? So we cannot connect 0, 1, right? The question is how you are able to determine that there is a cycle being formed. अच्छे से सोचो. We started with DSE concept only, right? So how can you say 0 and 1 if I add an edge will become a cycle?
If we add to parent of it,
So what will be the representative of 0? Let's say something.
1.
Let's say 0 representative is 1. Okay. What will be the representative of 1?
1 itself.
1.
So can I say if they are in the same component, if I add them, will it become a cycle?
Yes.
So what we will do is in this kind of thing, we will not do anything. Okay. Okay, we will not do anything. Now, what the next part? This is the next smallest one, right? Okay. And what do we have finally? Let's say we will add one more edge. Now, which one shall we consider?
5 0.
4, 0.
So we will consider 5 0 since 5 0
5,
is
0.
7, right? So if 5 0 is 7, can I connect them?
Yes.
You can. And is the tree ready?
Yes.
Yes, is the tree available, right? Because 1, 2, 3, 4, 5, 6. There are 7 nodes, there are 6 edges, and you have the MST ready with you. The cost is, since we are, however, maintaining this, so we can just add it up. 3 plus 5 plus 7, which is how much? 7 plus 15 plus 2,
15.
17, 21, 24.
14.
So for this tree, the answer is 24. Okay, so it's very simple. Go in a increasing order. Okay, go in a increasing order. As soon as you uh, take any two nodes, okay, I mean any edge between two nodes, see whether they are in the same component or not. If they are not in the same component, go ahead and merge it. If they are in the same component, they will always create a cycle, so don't merge them. Okay, so shall we write a quick code, or do you guys think that you can do it? What do you say?
Yeah, it's better to write.
Okay, so is the concept clear, everyone?
Yes.
Yes.
Yeah, bro.
So we are using DSU only for like whether it is forming cycle or not, right?
Exactly, correct. Okay, so what information do we need? N, that is number of nodes. Okay, we also need number of edges and the input is this, like this. Okay, u to v having a weight w. Okay, so can I create an single array, I mean 2D array? Is it fine? Is it okay, guys? Edge node u to v having a cost w. Is it fine? अरे हाँ ना बोलो भाई तुम
Yes.
इसमें इतना
Yeah, yeah.
डेटा स्ट्रक्चर है इसमें 2D array I created. What, Sam?
Yeah, got it.
Okay. Next, what I need to do? I need to sort it up, right? Sort the edges, correct? In the based on ascending order.
Ascending one.
So I'm just writing a lambda. So okay. So what I have done is I have sorted based on the a of 2, b of 2 means this way.
Wait.
Okay.
Yeah.
So once done, probably we have the DSU ready. So DSU d equals to new DSU of n. Okay. So what we will do, we will int cost equals to 0 for int x in h, int u equals to x0, int v equals to x1, int weight equals to x2, right? These are the things which we have, right? Now if d dot find of u is not equals to d dot find of v, what does this mean? If they are not in the
Same component.
same component, okay. And what I need to write after this?
Merge.
Print cost.
Okay. So shall we run it? Shallow. We shall take this graph itself. Okay, how many nodes? 1, 2, 3, 4, 5, 6, 7. There are 7 nodes. How many edges? 1, 2, 3, 4, 5, 6, 7, 8 edges, right? Or 1, 2, 3, 4,
Yes.
5, 6.
8 edges.
There are 8 edges. 3 say 4 is having a cost 5. 3 say 5 is having a cost 3. 3 to 4 having a cost 5. 3 to
5 cost 3.
okay.
5 to 0 cost 7.
5 to 0 cost is 7. 4 to
0 cost 8.
and what do we have now? 0 to 6 is 2. 6 to 2 is 4. 0 to 6.
6. 2.
6 to 2 is 4.
Okay. 2 to 1 is 3. 2 to 1 is 3. 1 to 0 is
5.
did we get this?
Yes.
Yes.
Okay. So we have the things available. Okay. Now they might ask you that whether it's possible, whether every time a spanning tree is possible or not. So what will you do in that case?
Can you repeat that question?
How to know whether a spanning tree has been successfully formed or not? So can I say if a successfully tree has been formed, can I say there will be n minus 1 edges for sure?
Minus 1 edges.
So you can kind of keep an edge count in count 0. Okay. Count plus plus. If count is not equals to n minus 1,
Not found.
then dot impossible or okay. Clear? So yeah, so how the questions would be like, say, okay, so one question for you guys. So you have found minimum spanning tree, right? How about maximum spanning tree?
Sort in reverse. Like,
Short deliveries.
Correct. So if you
yeah.
go like that, it works. Okay.
Mm.
But let's say, so we are kind of uh, object-oriented programmers, right? I mean, so what we do in a real life scenario is like we kind of keep this in a separate method and return the count, right? I mean, return the cost. This is what we do as a real life programmers. True. I mean, इसको मैं separate method पे लिख दूंगा, ठीक है? I will write in a separate method. Now, since the question is about like you have to find maximum spanning tree, what you are doing is you have to go and change this condition, correct? Instead of a of 2 minus b of 2, if you write b of 2 minus a of 2, it's done. Your question is done. But what you are doing is you're going to that method and you're changing this, which is not a good way of design. In that case, what will you do? Let's say already the things are done. These things are already been done. A I have written in a separate method, and I don't want you guys to touch this method. So what will you do in that case? Is the question clear? First of all, I mean, what we are trying to achieve.
Yeah, can you repeat again?
This thing, A1,
Hmm. Hmm.
I will write in a separate method. Okay.
Okay.
Now, what we will return from that is we will return the cost.
Okay.
We have the spanning tree ready in a separate method. If we
Okay.
just call this method with a given graph, it should return you the spanning tree ka cost. But
Okay.
as a programmer, okay, this implementation you know is always correct. But
Hmm.
what you are trying to do is, since you are asked to find maximum spanning tree, you are going inside the method and changing this one, right? B of 2 minus A of 2. This is
Hmm.
a violation of oops. Okay.
Hmm.
So in that case, what will you do?
You should reuse this, you're telling, right?
Exactly. You should reuse. So how will you reuse?
Okay.
Think of it for a minute. सब लोग सोचो. Deva, Manan, Sam, think of it. Okay, should I give a hint?
Yeah.
There is only a single line change here. What if we do
Okay. At the at end we should also
exactly
do
correct?
cost also, right?
Yes, minus one. We should multiply with minus one. So in that case, will we get the answers?
Yes.
Yes. So the simple change is if you do minus one, what happens? Every weight will become negative, right? Right.
Hmm.
And what MST is, MST will take the, so out of minus 10 and minus 3, it will take the minus 10, right? And when you get the answer, you will get it as minus 10. So if you do again with minus, if you multiply with minus 1, you will get it as 10, and 10 is your answer. So this is a cool trick. Okay.
Okay.
Just instead of
Just can
changing,
you run this program again? No.
uh okay, so you want me to run this program. Okay. So what we
Hmm.
need is we need this also.
Hmm.
So can we copy this? Let's see. we get 32. So इसमें 32 कौन सा आएगा शायद. This is
10, 8.
this is for sure.
Hmm.
This is for sure.
Hmm.
This is for sure. It has to be.
Hmm.
So we cannot attach.
And 4.
Uh, we can attach this, I guess,
Hmm.
right? And there has to be like most probably it should be this. कितना हुआ? 7, 17, 25, 30. Uh, did we do something wrong? 7, 8, 7, 15.
नहीं नहीं करेक्ट 15 20 30 ज्यादा हो गया
So did we get? Oh, we got 32. So somewhere,
32 है
somewhere. Oh, like where is this edge 10 here?
We
we didn't
have
write
Uh,
Hmm.
so okay, let's draw. So did we miss 10 or what?
Yeah, I think we have missed the edge.
Okay, so we missed that edge, right? And all the edges are same. Is all the edges are same, guys?
yes
So now nine edges, right? In total, or 8 edges itself? 9 edges. 9 edges. 1, 2,
9
3,
Hmm.
4, 5, 6, 7, 8, 9. Okay, now 9 edges. So what
Yes.
we'll do is we'll just write everything from the top. 3, 5, 3. And
4 to 110.
did we get no? Perfect one. 37. 8,
Yes.
15,
Yes.
30, 33, 37.
Yes. Nice.
Nice, right? So this is what.
Hmm.
Clear?
yes
So we will do this again. Okay. So this is the trick for this one. Okay. There can be some kind of questions like, like there was a maybe some terrorist has attacked and like there was the roads. Okay. So there was a city and you can go from some place to some place, but somehow like something happened. There was an apocalypse and like the roads got destroyed. Okay, now the engineers came and they asked that, okay, in order to connect any u comma v, you have to pay cost of, let's say, some ci. Okay, so what government want to do is like government wants to create minimum roads to make sure that all the cities are reachable from any one of them. So can you see this problem is again a Kruskal's problem, a minimum spanning tree problem.
Yes.
Yeah. So this is
yes
so it's all about like you have a technique ready. Okay. It's all about figuring out how to implement that. Okay.
correct